Dr. Kyle Wickings is a professor in the Cornell Department of Entomology. In his lab, he focuses on soil arthropod ecology and turfgrass entomology. And he's done some research on jumping worms, and I believe that is why so many of you are here today, because it's certainly a popular topic. We have a lot of questions. So go ahead, Kyle. We are excited to learn about jumping worms.
All right. Thanks, Mara and Matt. It's good to be here, and thanks everybody for joining. It looks like we got a pretty good number of people here. Um, as Mara said, I'm the turfgrass entomologist here. I'm a soil biologist, and our work spills over the edge of turf into kind of the landscape and managed forest setting often. And it does that with invasive jumping worms. So that's why I'm going to be here today talking about jumping worms. I'll talk mostly about their impacts and monitoring and a little bit on management. Unfortunately, we haven't pushed the management tools down the road as fast as I would like, but it's something that we're working on and happy to chat about that with folks. So let's get started. All right. So jumping worms, there's a lot of common names for jumping worms. You probably have heard of snake worm, green stinkworm. These kind of all relate to sometimes different species of jumping worms. I'm just going to refer to them all today as the jumping worms or invasive jumping worms. Um, Together, the species that we are dealing with here originated from Korea and Japan, and we call them the pheredamoid earthworms. That's kind of the big taxonomic umbrella that they all fit under. In North America, we've got about 16 species that we've had records of their occurrence, and in the Northeast, that's about 3 species that we typically deal with: Amynthus agrestis, Amynthus tokiensis, and Metaphyra hilgendorfi. They tend to behave similarly enough from what we'll talk about today that we'll just kind of lump them all under the jumping worm umbrella. And this is an image of a jumping worm right here. Before we get into life cycle and management too far, I just want to talk about, or their impacts too far. I want to talk about sort of distinguishing jumping worms from other earthworms. And we'll do that through sort of a generic European earthworm on the right. So there's some features that are helpful. I would say, just to start this off, that there's a lot of gray area around this and subjectivity and sort of like your perception of some of these traits. So just know that going into it. But let's talk about these traits, because I think together they can be pretty helpful in knowing whether or not you're looking at jumping worms. The first actually deals with their life cycle and when you'll see worms in the environment. So if you're out in early winter and or early spring, late winter, and you've got a thaw and things are warming up and you are seeing adult earthworms, it's very unlikely that those are jumping worms, because the adults of jumping worms don't survive winter very well. So they typically are really surviving that winter in the egg or cocoon stage. And the cocoon is like a leathery casing that's on the outside of one or more eggs to help survive conditions like that. So we call that the cocoon. So that's really the phase that is going to survive winter and what would be present in that early spring window, whereas you could be seeing adults of the overwintered European worms in spring or late winter. So very helpful. Oftentimes you're out really ready to start gardening and turning things over, and you're seeing kind of squirmy earthworms at that time. And there's a really low chance that those are jumping worms. So you can always ask someone in cooperative extension, though, if you're not sure, but just a heads up on that. The next is sort of their visual appearance. Now, the European earthworms, this is a very broad group of many species of earthworm, but in general, with the jumping worms, you can see that they tend to have this darker appearance. Oh, let me get on the right screen here. It's darker appearance to the back side of their body. And yes, earthworms do have a back and a belly side. And with the jumping worms, it tends to be a little darker on that back or dorsal side, we call it. They do tend to feel slightly rigid when you're holding on to them. But again, this is where it gets a little subjective. If you had them side by side, you could compare all of these things. Most people here have handled earthworms, at least night crawlers, before. But yeah, the jumping worms do tend to be a little more rigid and kind of like snake-like in their feel than European earthworms do. The next thing I want to talk about is this feature called the clitellum. So this is a really useful trait for distinguishing the earthworms and identifying jumping worms, but you only have this feature on reproductively mature earthworms. So this is the jumping worm again on the left, and you can see this clitellum is fairly close to the head, and it's fairly uniform. It's really smooth. It doesn't protrude out from the body very far. And if you were to look around the whole perimeter of the worm, you would see that it's very uniform in its thickness as well. So it's very smooth and continues all the way around the earthworm. Whereas with the European species, you can see it protrudes a little bit from the sides. It doesn't actually continue all the way around. It's more like a horse's saddle on the worm, and it's much further back from the head of the earthworm as well. So those are pretty convenient traits for distinguishing the jumping worms from other earthworms in the landscape. Again, though, you need a reproductively mature worm to do that. The next is behavior. This is kind of a know it when you see it sort of characteristic, but and again, a lot of people will see an unusually spastic European earthworm and think, oh, this is a jumping worm. But typically with the jumping worms, they will literally skip out of your hand if they're very active. So if it's warm and you're trying to hold one, they'll often get air and you'll have a hard time holding onto them. So it is quite different than handling the European earthworm species. And a lot of people will describe their movement as a little more snake-like than sort of contracting and expanding. The next feature is more related to their effect on the soil rather than their own morphology, but it's how they produce their feces, really. So the jumping worms are really transforming that whole top layer of soil. I have some pictures of that on the next slide, whereas the European earthworms are really making more confined mounds of soil with their casting material or their feces. We call that casts. And people have sort of likened jumping worm casts to like coffee grounds or taco meat. Everybody's got their own favorite food stuff that they compare it to. So one other feature, we see this commonly in the field when you're handling mature jumping worms, they'll often sever their body into two parts and you'll see the sort of head and tail fly off in different directions. I think it's a defensive behavior to avoid predators, but we don't really see that with the European worms. It does not happen with every jumping worm though. So don't expect, oh, if it does that, or it's got to do that to be a jumping worm. It just occasionally you'll see that happen too. Just as a warning that you might have that happen when you're handling. So, all right. So this is a really great image here, just showing on the left. This is a soil. This is another real nice picture from University of Wisconsin-Madison Arboretum from Bradley Herrick. You can see on the left, this is soil that's been heavily engineered by jumping worms. Now, bioengineering is an ecosystem service that all earthworms do to varying extents. So this is where it gets difficult saying whether this is a problem or a good thing, but they very aggressively and heavily will engineer that top couple inches of soil like this. So these are aggregates. This is like vermicompost, but it's just incredibly loose. There's really no connectivity among those aggregates. And it can be where some of the problems are associated with jumping worms. On the right, though, you can see a soil that doesn't have a lot of jumping worm activity. There's more bare soil without that aggregate appearance. You can see a lot more leaf litter on that side as well, likely because it hasn't been consumed by the jumping worms, which is really what they're doing. They're feeding on that forest floor leaf litter or organic material like compost at the surface. So really great sign. This is often the first thing people will see when they're encountering jumping worms is their casts before they see the worms themselves. And just as an example of what a typical European earthworm cast looks like in a lawn, that's what this is on the right-hand side in the grass here. So this more very distinct and confined mound. All right, let's talk about the life cycle. So I talked a little bit about this on the 2 slides ago, and it really is the cocoons that survive the winter the most for jumping worms. There are some exceptions to this, but for the most part, it's the cocoons, and they can survive quite cold temperatures down to -10 Fahrenheit. Whereas you can see for the adults, it's a much more narrow range between like 40 Fahrenheit and 90. Outside of that, the adults tend to start dying. So they really don't have a lot of ability to survive harsh conditions. But it's that cocoon bank that really gives them their superpower. You can see these cocoons here again next to this penny. They're quite small. They're the color of your soil, so very easy to overlook them and not know that they're there. Once temperatures get at or above 50 degrees, especially the soils, that's when we start to see this abrupt appearance of the juveniles show up. I say it's abrupt because they are there and they can be in quite high numbers, but you can also see that these juveniles are quite small. So it's like about an inch or just over an inch in length. So very, very small, somewhat transparent or translucent, but they can be in very high numbers in your soils. So this is really what's going on in your spring. Like right now, this is sort of the phase we have of jumping worms in the soil. So not likely to know that they're even there if you haven't seen them on your property last year. Once we get to early July and late August, though, that's when our reproductively mature adults start to show up. And all of a sudden you're noticing them in the system. That's when the panic kind of sets in if you haven't had them before. So And this is the time when they're capable of reproducing and producing those cocoons and releasing them into the soil. And it's a pretty broad window, like July through November, when that happens. And they can be in very high numbers as well. That really is one of the problems with jumping worms, is this inherent like seed bank of their cocoons that can carry over to the next year. Some of those cocoons will hatch before winter hits, but for the most part, it's their ability to survive winter that allows them to be successful, so they won't hatch. Okay, let's move on and talk about their impacts in the landscape. So there's been a lot of work on the effects of jumping worms in forest systems, and we know the impacts fairly well. But what about when we get out into these residential settings? We've got raised beds, gardens, mulch tree rings, and lawn, that sort of typical habitat spaces. What do jumping worms do in these kind of settings if I introduce them in compost, for example? So we've looked at this in a variety of different trials. And surprisingly, just like any other earthworm, they do the things that we assign as beneficial traits to earthworms. So they increase nitrogen levels in soil. This is just looking at the cycling rate of nitrogen. And when jumping worms are present, sorry, on the left, I keep going to the wrong screen. But on the left, you can see with jumping worms, that nitrogen cycling rate is higher. So this is kind of the rate at which they're mineralizing nitrogen and making it freed up for plants to take up. So that would be a good thing if you're thinking about the process of biofertility in your soils. And you can even see in this case, in this trial, we saw an increase in turfgrass greenness in response to that. So they're actually, the plants are responding with green, at least greenness as the index in short order following that. So, these are the kind of things that we talk about as beneficial processes with earthworms. I think the challenge comes in the fact that they're often mineralizing so much nitrogen that it's often more than the plants could use at any one time. So that's where we get risk to things like nitrogen leaching and runoff from a system. So this is sort of the chemical side of the benefit, or fertility side, that comes from the presence of earthworms, keeping in mind that it might be more than the system actually needs or can use. But where a lot of the real problems come in with jumping worms is in the production of these casts, or this fecal material. So this is just some data that we generated looking at soils that you apply hardwood mulch to, or compost, or nothing. It's just a bare control soil. And in all cases, we saw high rates of the production of this casting material. And just to kind of put this on a scale that makes some sense, if you just picture like a square foot under your feet, it's like dumping a pound and a half of coffee grounds in a single square foot area. Like, it's a lot of material that accumulates over that first season when the jumping worms infest an area. So again, these things are high in nitrogen. They're stable little aggregates of soil. So kind of a good thing, but there's just so much of that material. It's not well connected with clay particles. So it's very, very loose. And especially if you get into a system where you have a hill slope, it can really cause a lot of erosion, and it just over aerifies the root zone for plants. So that's where, like, it's a good thing, but it's just a little too much of a good thing. So, all right. Here's the slide about what we can do. And frustratingly, it's kind of the same slide we've been talking about in all of my jumping worm talks, because we're still working on control solutions. There are no products registered in New York for earthworm control as a whole. So it is a slow process, but these are some of the things that you can do at various stages of wondering if you have jumping worms to knowing what to do when you confirm you do have them. And the first thing I'll lead with is just the fact that DEC categorizes jumping worms as prohibited invasive species. So you can't knowingly move them around without, I had to get a certificate to actually a permit to grab them in one place, bring them to Geneva to actually do research on, and have a very strict protocol for how we're going to confine them. So this goes for topsoil or compost that you know is infested with adults or possibly the cocoons. So just knowing that is helpful going into this. And makes it really doubly important to learn the signs and symptoms of jumping worms, whether it's the casts or the worms themselves. You can inspect mulches, compost, and topsoil for the worms. It's easiest to do the bigger the worms are, but being able to recognize them and sort that material for their presence is really helpful, especially if it's a decision where you're about to bring some material onto your property. That's a good skill to have. Like, if you know it's in the material you're looking at, you could pick a different option. Mustard powder is one way that people will do this. Now, this is not a control method or a management method. It's just a monitoring tool. So you could use this to flush a soil profile in a small footprint and see, do I have jumping worms in that, live active jumping worms in that soil or compost or mulch. It's about a third a cup of culinary mustard powder mixed in with a gallon of water. It does not mix well, just a warning there. You have to really agitate it to make a slurry of this stuff, and then flush it in. So you really saturate the top couple inches of soil, and then let it sit for half an hour or so. So we're working on some cocoon sieving methods. I'll show that on the next slide. But just to show that you could also look for cocoons in material, much more challenging, but I'll talk about that in a second. The next step I would say is pretty helpful is if you're using compost in your system, making sure you're sourcing compost that you know was properly treated for pathogens, because if it hits the temperatures and duration that it should for pathogen management, that is sufficient to kill jumping worms in their cocoons as well. So you're kind of getting the double benefit of that. The problem, I think, is if that compost sits again and can be colonized by jumping worms sitting in a windrow later. So really thinking about your sources is helpful for that. Checking for castings under amended beds. So this is a picture of us on the bottom left here, sorting and collecting jumping worms for research, but this is really what you do. You basically very lightly rake back the top mulch layer, and if you have jumping worms active in those beds, you will see them immediately under the surface. Some of you are probably seeing this in your heads already from your own systems that you're managing, but yeah, you don't have to look very far into the surface. The thing about this ecological group of worms is that they're very, very shallow in the soil profile. Keeping records of your material is a really important one, especially if you all of a sudden have an abrupt appearance of jumping worms one year. If you had kept records on what sources of material you brought in, where you got it from, which potted plants did you purchase, and where did they go in the landscape, that can really help you do the detective work to kind of back up and figure out, well, how did I actually introduce jumping worms and where from? Oftentimes we're a season or two in when we talk to people about jumping worms on their property, and they just cannot figure out what of the 5 different things they did could have been the source, and it makes it a lot harder to get it under control. So using bare plant roots when possible for plantings. Obviously, this isn't possible for everything, but it's obviously a way that you can minimize bringing in new soils. So to keep things cocoon and worm free, that is one strategy that you can use if you have access to that and it's feasible for your program that you have at your property. I say also in the same vein, being aware of community plant swaps. I think these are great events. They're great for extension. They're great for community building and getting great new sources of plants. But there have been a few plant swaps where people have also traded jumping worms unknowingly. So it's something to think about how we do plant swaps in the future. I think is to maintain that kind of a resource is going to be important. And then lastly, cleaning equipment and tools. There's a really broad feasibility scale here. You might have the capacity to brush off soil from shovels in a bucket of water and then screen that material. That's great, especially if you don't want to move things around your own property. But if you are a commercial operation and you're moving a couple skid steers daily among properties on a trailer, that power washing that between every property is not necessarily the most feasible. But to the best of your ability, having a protocol for your team or your family to clean material off of these things, especially if you're borrowing equipment from neighbors and sharing it. So is a great thing to do as well. So just to end this, I wanted to show this device we've been working on. This was funded by the DEC to develop. One of the objectives was to develop this monitoring method. This is all stuff you can get at a big box store, Schedule 30 PVC and couplers, as well as some stainless steel mesh you could buy on Amazon and hot glue. That's really all it is. And we stack these up with these 4 different sieve sizes, put a soil sample or compost into the top, blast it with a hose, and sort of brush it with our hand through these sieve sizes, and the cocoons will end up in the bottom. So that is a way that you can scout new material if you're about to bring it in or you're about to move material off your property to test whether it has cocoons or not. So it's not perfectly streamlined, like you have to sort these bins of water afterwards, but at least you'll know it's in that fraction if it's going to be there. So it's a useful method for that. And anybody's welcome to reach out to me. We're not trying to build these and sell them, but if you want to just know how we built it, we're happy to describe that to you. So a couple of resources to close out. We have a jumping worm fact sheet that you can get to with this QR code here. You can scan it. It's very easy to find if you just Google Cornell jumping worms. You'll find the fact sheet that way as well. And if you're really a nerd about earthworms like me, you can check out this article we wrote in the New York State Conservationist with a group called the J-Worm Working Group. This is a number of folks in the Northeast working on earthworms, and we just wrote this article generally about what earthworms we have in New York State and how they differ from one another. So yeah, so those are my slides, and I don't know where we're at with time, Matt and Amara, but I'm happy to take questions if we have them.
Thank you, Kyle. That was great. We have many questions, and we can probably, I'm just going to scroll through quick and see. I think you already talked about um, kind of there's a question about the long-term impacts of jumping worms on gardens, and I think you talked a little bit about their impacts. Do you have anything more to say about that?
Long-term impacts.
Yeah.
Yeah, so I can at least mention some of the things we've been seeing. We've talked to a number of people, especially running community gardens and things like that, that have sort of found, they kind of shifted the needle from focusing on eradicating them, which I think everybody knew up front, even these people, that it wasn't going to be super feasible to do. But they've kind of shifted to thinking more about how do I garden with them and around them. And many of these folks have found that there are a number of plants that seem to tolerate the jumping worm activity fairly well. So I guess in the long-term sense of behavior and how practices might change, that's one thing that I've seen. I've also seen this pattern where beds will get infested, and with slowing down on amending those beds, so you're not feeding jumping worms with things like compost year after year, you can kind of make that bed less suitable for the jumping worms. The problem is if you live in a complex habitat where you might have them recolonize a bed the minute you recompost it. So there's kind of like this, what organic materials are you using, and are you really getting rid of them on your property, or just kind of having them leapfrog around year to year, which we don't quite have an answer to yet. But yeah, it's not like once you have them, they're going to be there forever. It definitely, we see years where their numbers really, really drop down if you slow down on the amendment of those soils.
Okay. There are just so many questions in the chat. I think I will save these. And if you would like to answer any that you see have like quick answers while we're doing our IPM minute, you're welcome to do that.
Okay, great. I'll
Otherwise,
skim through them then.
I'll save them and we'll follow up with you on those later. I am unsurprised that this was such a popular topic. I know a lot of folks have a lot of questions about them, and thank you for being here. I am going to pull up my slides because I am doing our IPM minute this month. So I am the biocontrol specialist with the Cornell Integrated Pest Management Program. In addition to hosting What's Bugging You First Friday, I spend a lot of time thinking about how we feed friendly insects. So this month we are on step 7 of talking about ways that we feed friendly insects. And our focus this month is if you planted some seeds last fall, which we talked about, how are you going to find them in the spring now that they are germinating next to inevitably some weed seeds? And so what I have in this picture here are some of the seedlings I'm most excited about right now. You can see these 2 seedlings with these really round cotyledons or first baby leaves, and one of them has a very deeply palmate leaf forming. These are some wild lupins that I'm starting at home that I'm super excited to see. So we're going to talk a little bit about where you can learn more about how to recognize wildflower seedlings if you planted seeds last fall outside and now you're trying to find them and see if they're growing. Just as a reminder, this series on feeding friendly insects, we're focusing on both pollinators, like this cute bumblebee visiting a blue false indigo, and insect natural enemies of pests, like this lacewing larva on a purple coneflower. These are what I'm considering friendly insects, and we're talking about how to provide them with food, shelter, and protection from things that harm them. I'll have this QR code in a few places on the slides. This just takes you to a part of the Cornell IPM website where we have a lot of information about creating habitat for friendly insects. And you can plant annuals to feed friendly insects. In this series, we're talking about perennials. They can take some time to establish, but they are really quite rewarding once they're growing. So last year we talked about the installation steps having to do with getting your soil ready and doing a fall planting. And then this year we're talking about the maintenance steps. We talked about cutting your stems in late winter. We talked about waiting to clean up your garden. And now we're on step 7, looking for your seedlings. The goal here with looking for your seedlings is to be able to recognize wildflower seedlings versus weed seedlings. One thing that you can do in the fall when you plant the seeds that helps with this is to plant the seeds in a line. So in this picture on the left of your screen, I have some seedlings just starting to emerge. They have really fleshy cotyledons that look like beans because they are in the legume family. These are blue false indigo or baptisia. And if you plant your seedlings in a line, you kind of know where to look for them. I have a lot of resources on a blog post that I wrote last spring, I believe, about how to recognize seedlings of different wildflower species, and we'll put that link in the chat. I just have a few pictures here. So in addition to the baptisia, we have an echinacea. The first true leaf of an echinacea is produced just one leaf, as opposed to penstemon or beer tongue, where the true leaves are produced in pairs. The echinacea leaves have a little bit more fuzz or hair on them than, for example, the beer tongue. The beer tongue tend to have purple edges around the leaves, but the echinacea doesn't have nearly as much hair or fuzz on the leaves as Rudbeckia does. So even with these really small seedlings, if you learn some of these key characteristics, it can make it easier for you to find them. And again, there's a link in the chat with some more pictures and some more notes about some of the characteristics that make these seedlings easier to spot. I will also put in the chat a link for a seedling gallery from Ernst Seeds. Ernst is one company, not the only one, where you can buy wildflower seeds, and they have some resources on recognizing seedlings as well. And that is all I have for you today on our IPM Minute. If you like seeing pictures of wildflower seedlings and would like to watch me continue to find wildflower seedlings this spring, you can follow me on Instagram. There's a link to my blog. If you have questions, you're welcome to send me an email. And our final step in feeding friendly insects will be weed management, and we'll do that in July.